Today we're going to talk about the key features of any function, and we're going to be able to point out all of these properties. I just want to remind you about which each of them are. First of all is domain. Those would be the x values on your graph. And range, of course, will be the y values. And we will describe them. X and y intercepts are where they cross the axis. Increasing and decreasing intervals. This is how the graph is moving up or down. How the graph moves up or down. Okay. Then in behavior, we're going to talk about that and describe it better for you. And then maximum minimum is, these are just turning points. And some of your graphs will have more than one turning point. Okay? And then something that's new in Math 3 is positive and negative intervals. So we'll talk about what those are. Okay? So the first thing I want to look at is this particular graph here. And we're going to name all of these features that are listed. Okay? So the first one is domain. Now domain, we're going to look at the x-axis and look and see if on this graph we are using all of the x's. And we are. If you look down, you see all the x's, and as it moves up and down, it would be, it would use the rest of them. Okay? So in this case, this polynomial has a domain of all real numbers. So we would say negative infinity to infinity. And we're going to use interval notation instead of less than or greater than. Okay? So let's talk about the range. The range is the y. So we're going to look up and down this axis and see if we're using all the y's. And if you notice, we are going to use all the y's because as we look down this graph, it's going to continue again. All right? So we're going to look at negative infinity to infinity again. Okay? Now, let's talk about increasing intervals. We want to see where is the graph increasing. Where is it moving up or down? So, if we start left to right, the graph is going upward in this area. And we look along the x in which that occurs. So, from negative infinity until we get right here at negative 5, that graph is moving in an upward motion. Then if we continue on, we see that it's moving downward. It's decreasing. Starting at that negative 5 until we get to 1 on the x. And then we turn around and we go increasing again, picking up at that 1 to infinity. So we want to look along the graph to see how it moves up and down, and we determine that interval based on the x. Okay? Now, let's talk about positive and negative intervals because that's different. Okay? So, I'm going to erase these little markings. Okay? So, positive interval. So when we look at this graph, the positive portion of the graph is from 4 to infinity. Okay? Along there, the values are positive. The y values are positive. Now down here, all of these are negative. So the negative interval is going to be from negative infinity until we get to 4. And then it will change. Okay? Now, let's talk about extremas, because they call them extremas instead of maximum min, okay? These are where we turn. So they're called a relative maximum, a relative minimum, okay? So the max would be this turning point, okay? The max is negative 5, 0. Okay? The minimum is this turning point. So the minimum or the extreme minimum is 1, negative 100. All right. Now the last thing we're going to do is end behavior. Now when you're looking at end behavior, you want to actually look at the ends of your graph. Okay. Now they're going to start out with x approaches negative infinity. F of x is approaching what? You're going to have to fill in that blank. Then we're going to say x is approaching positive infinity, and f of x is approaching what? You're going to have to name that. So let's look at both of these ends. Over here, this is the end. It keeps going, right? So this is x approaching negative infinity. Your y is going down at that point. So it's approaching negative infinity also. If you look at this end, x is moving to the right, approaching positive infinity, and y is approaching positive infinity as well, because it's moving up. Okay? So that is end behavior, and this happens to be a cube function. So it looks like a cube function. Okay? So let me give you a different kind of picture. Let's see what we come up with. Oh, these look familiar. This is a absolute value. That's right. So let's talk about the properties of this. Domain, that's your x's. So if this graph continues, we will use all the x's. So that's going to be negative infinity to infinity. The range is different on an absolute value. You notice down here we are using the y's, but I stopped using the y's at 2. So our range goes from negative infinity to 2, and it includes 2. All right, now notice I put a different grouping symbol there at the 2. That means it equals. Okay? Now let's look at increasing. We read from left to right, and from left to right, this graph is increasing until it gets right here. So from negative infinity till we get to 3 on the x-axis, we're moving upward. And then we turn and go in a downward motion. So we're picking up at 3 and going down to positive infinity. So x would be going to positive infinity then. Okay? Because we turned and started decreasing. Now let's talk about the intercepts. Okay? Usually, if you're going to graph an equation on Desmos, it'll give you a dot for the intercepts. All right, our y-intercept is at negative 4. Our x-intercepts, there are 2. One is at 2 and one is at 4. And we'll name both of them. Okay, now I'm going to skip in behavior. I'm going to go down to whether this is a maximum or a minimum. Is it the highest point on the graph, or is it the lowest point on the graph? This is the highest point on the graph. So we have a maximum at 3, 2. Okay? Now let's talk about end behavior. Remember, as x approaches negative infinity, f of x is approaching what? And as x approaches positive infinity, f of x is approaching what? All right, let's look at where x is approaching negative infinity. X is going to the left on this side of the graph. While x is going left, y is going down. So it is going to negative infinity. Now, do you notice that the other side is going in the same direction? So whether x is going negative infinity or positive infinity, this graph is moving down to negative infinity on the y. So, as x approaches negative infinity, f of x approaches negative infinity. As x approaches positive infinity, f of x approaches negative infinity. Okay? So let's see if a parabola is any different. It acts the same way an absolute value does. Here we have domain, all real numbers again. The range has an ending point. We stop at 3. So we go from negative infinity to 3, and we include 3. This graph, like the absolute value, moves upward first. So increasing from negative infinity till we get to 4 on the x. And then we turn and we go in the opposite direction. So decreasing from 4 to positive infinity. And these intervals are named along the x in which they occur. So don't let that fool you. We are not naming the y, we're naming the x. Okay? Alright, let's talk about the intercepts. We have a y-intercept right here at negative 9. And we have 2 x-intercepts at 2 and 6. This again is a maximum, the highest point on the graph. It is at 4, 3. And then our end behavior, as x approaches negative infinity, as x is going left, y is going down. So f of x is approaching negative infinity. And as x approaches positive infinity, as x goes to the right, the graph is still going down. So f of x will still approach negative infinity. Okay? I'm hoping that clears up positive negatives, range, domain, all of those things. Okay? So I wanted to show you this particular question. I'm going to shrink it a little bit so I can show you everything. Now we need to tell what intervals are decreasing, increasing, are positive, and are negative. And I've got 4 choices down here. The first one is negative 1, 4, negative 1. So we're going to look here. Negative 4, negative 1. Now it's going in an up and a down motion, so it's not looking for increase or decrease. This one's looking for, is it positive or is it negative? And it happens to be positive up here. So we're going to put this negative 4, negative 1 right here. Okay? So let's see what the next one is. Negative 2 and 0. Now if you look at this, all of that is decreasing. It's going down. So we're going to put this under the decreasing. Okay? Alright, the next one. 0, 2. So here's 0. Here's 2. In this interval, it's all positive, right? It's all going upward. Does that make sense? No. It's all in the negative portion. This is negative. Negative 2 to 0, it's negative. Alright? Now let's look at this one. This last one is 0 to 4. Well, that one looks like increasing. Okay? So you've got to be able to look at a graph. If we're just looking at the portion down here, that's a negative. If we're just looking at this portion up here, that's positive. But if we are looking where the graph is moving up or where the graph is moving down, that's increase and decrease. Okay? So I'm hoping that cleared up the properties for you.